Oopsy supports a streamlined workflow from a well-established platform for digital signal processing into a promising emerging hardware platform highly suitable for DMIs and NIMEs. So how does it work? If you have a max patch, then all you need to do is drop in an Oopsy object corresponding to the hardware that you have. And then every time that you save this patch, it's going to generate the code for the DAISY hardware. And if the hardware is plugged in by USB and ready to flash, it'll also upload the code to the device. You could also start with one of the template patches that are supplied with the Oopsy package. Oopsy has full-featured support for some fixed format hardware configurations, as well as a flexible data-driven JSON schema for more open-ended DIY configurations. The workflow applies a pragmatic and lightweight solution for mapping from existing resources to available features through a simple labeling schema, auto-mapping, and drop-in examples for common requirements. Regular inputs and outputs in the Gen Patcher will correspond to the audio jacks on the hardware device. To access the knobs, CV inputs, gate inputs, and so forth on the DAISY hardware, use param objects in the Gen Patcher. The name of the param will address a particular control or CV or gate or knob. Oopsy will always try to map all of the hardware controls, such as knobs and switches, to any available parameters. Use out CV 1 and 2, out gate 1, and so on to address the CV and gate outputs on the hardware. Oopsy provides a few objects for handling raw MIDI I/O within Gen patching for maximum flexibility, as well as streamlined MIDI input and output objects for specific MIDI events, such as continuous controllers and drum note velocities. Oopsy can also support loading WAV files from the SD card if you have more than one Gen object in your patcher or in its sub-patchers. Then when you build, each will be available to switch between as different apps. MIDI-enabled DAISY devices can switch between apps in response to program change messages. The firmware that it generates benefits from optimizations possible with such a highly targeted workflow and incorporates practices to minimize program and runtime memory footprints, as well as features for reducing CPU overhead. The performance measurements indicate that Oopsy can be used to author and flash hardware with a broad diversity of commonly sought algorithms, from oscillators, filters, matrix mixers, sequencers, delays, reverbs, and so forth, at high fidelity and very low latency. Of note, tests demonstrated that the system is capable of an expensive digital oscillator design using an extremely high-resolution wavetable at 48 kHz and with a throughput latency down to 1/100th of a millisecond, which permits placing such algorithms within analog feedback audio modulation circuits covering the entire audible spectrum, and thus escaping one of the common problems of working with digital signal processing in hardware modular synthesizers. So we got some self-modulation there. This project is fully open source and incorporates a diversity of example materials, supporting industry, community, and pedagogical projects. There's a community with a lot of discussion on the DAISY forum focused on Oopsy. There's also tutorial and community activities at the Cycling74 website. And there are already a variety of users developing patches, both for the DAISY patch hardware and also for custom seed-based platforms. Thank you.